And also, you can also progress into management. A lot of people go into either project management or business management because even if you're studying engineering here at DCU, you learn amazing skills that allow you to take those positions on. Like at the moment, I'm taking an entrepreneurship class and a engineering management class just because it's really important that we have those skills going forward. So you can also go into further qualification and research. A lot of people stay in academia, they go on to PhDs, or even just get trained up in different fields so you can work across a variety of different projects. And as mentioned before, opportunities to travel and work abroad. A lot of companies have international offices or partners abroad, and they might be traveling between different sites, different factories, and different projects, collaborating with people all over the world, which is definitely something that I know a lot of people in my year are hoping to do. And a transferable accreditation and chartered engineer status. Again, when you graduate at DCU, you are recognized internationally as an engineer, which is really, really valuable going into your career. So, engineering at DCU. DCU was founded in 1980 and it has consistently ranked highly in the top 50 under 50 universities. We have over 100, I think might be even more than that again for clubs and societies, including an engineering society, which if you're in engineering, you can, even if you're not an engineer, we have some nursing students in that society as well, but you can get experience the fun side of engineering, which can be they've built their own drones, they've built their own 3D printers, they've built their own remote control cars. The society really gets around and does it all. But even if you want to do something else in DCU, we have everything from rock climbing to archery to Dungeons and Dragons to Taylor Swift. There's really a society out there for every student. So we have the best equipped engineering building in the country and also one of the best STEM teaching buildings in the country, which is the Polaris. We have strong academic and research track record and a strong industry links, which is really important and really useful when going on your internship, which all engineering students go on, which will mention later in this presentation. So DCU was ranked 23rd in the world and first in Ireland for its graduate employment rate in 2022, which again is very handy when you graduate and looking for a job. And DCU is also the first in the career development category in 2023 Global Student Satisfaction Awards. That was ahead of MIT, which when you're looking at for engineering is very, very nice. So just a quick reference for the DCU Solar Racing for anyone interested. Um, so DCU Solar Racing is a newly established student-led group. It was actually only set up in my first year when I was starting at DCU. It is Ireland's first ever solar racing car. So basically, it is a group of students that are grouping together to design a solar racing car. Um, they aren't even all engineers. We got some business students, we got some teachers, I believe, and computer science all collaborating on this one project with the main aim to build a full car that is solar powered to race around the world with the very, very big hope is to get it to Bridgestone World Solar competition in Australia, which would be over 3,000 kilometers in the outback. So if they're able to get it, that is absolutely amazing. And honestly, this team will still be working and trying to improve this design when you guys get here. So if you're interested in cars, this would definitely be a cool experience to get on board with. So women in engineering, DCU makes a huge effort to make sure that we are both inclusive and diverse in engineering and across the entire campus. So this is just a few references to some of the key women in DCU and in the engineering faculty, featuring Jennifer Bruton there, which is our executive dean, as well as a reference to the Women on Walls project. So if you ever come to DCU for any of our open days or any of just walking around, if you go into the Stokes building, you'll notice five very big paintings of scientists on the wall, all of which are women. And these are just a special acknowledgement for women in engineering and science throughout history. One of them even includes, if you've seen the Hidden Figures movie, which if you hadn't, highly recommend, um, which is about Katherine Johnson, which is one of the women who helped in the NASA project. So, courses. the important part of this presentation. So we have two schools. We have the School of Electronic Engineering and the School of Mechanical Engineering, which is perfectly timed because Matthew has just gotten in and he knows probably more about the electronic school than me.
Yeah, great. Thanks, Laura. I'm sorry for the delay there with the technical issues. But yeah, so as Laura mentioned, I'm in fourth year of electronic and computer engineering, and our School of Electronic Engineering has two courses. So my course, which is electronic and computer engineering, and then mechatronic engineering, which is shared with the School of Mechanical Engineering. Um, and then as well, we have our common entry to engineering, which kind of encompasses both schools, and we'll get to that later in the slides, just for the structure of each course and what you study.
So we also then have the School of Mechanical Manufacturing, which, as you can see, has five options. One of which is also the common entry into engineering because it overlaps on everything. So the main one that everyone would think of first is the one called Mechanical and Manufacturing Engineering, but we also have Mechanical and Sustainability, Biomed Engineering, and Mechatronics. Mechatronics is a very nice overlap between mechanical and electronic engineering. So, just a little breakdown of the engineering pathways in DCU. So, in first year, regardless of what you choose, you have everyone does the exact same classes. We share the exact same modules, and with that, we all learn everything from the foundation up. So, you'll learn programming from the foundation up. We'll start with all the basic sciences again, um, lab work, workshop, all of it. You get taught from the very basics, so everyone knows what they're doing when they get into second year. Then going to second year, you'll then branch off into your individual disciplines, and you can also apply to transfer if you wish, if you decide that the course that you entered in isn't what you want, or if you think, oh, actually, biomed sounds really cool and want to transfer, there's a high chance you'll be able to swap between them. And then you also have an option for a thing called integrated masters. So an integrated masters is basically you stay on for an extra year and you'll get graduate with both a degree and masters at the same time. It's a slightly more affordable option for a masters, and you also get a longer internship, which we'll talk about later as well. And just a quick overview of the course structure. So they're all 4 years, 5 years with the integrated if you choose. And we all have our internship placement in third year, which is 6 months if you are doing the normal route and 10 months if you're doing the integrated route. And it's a mix of continuous assessment and exams. You'll be doing plenty of lab work and workshop skills, and all of that will count towards your end grade. And it's also then 60 credits per year, which are divided across each of your individual subjects.
Yeah, so electronic and computer engineering. The way I describe this course, it's basically the kind of the meeting point or the interface between the software and hardware of every electronic device. So that could be your laptop. It's how the hardware, like the circuit boards, communicate with the software that runs on top of them. And because of that, you work across you learn across a wide range of topics. Everything from, as Laura said, programming. You'll learn that from first year, and you're not expected to have any prior knowledge of it. And you're brought through all the way to fourth year to now. You're able to code much more sophisticated projects. And you're also working with the hardware. So this is designing circuit boards, using electronic components. And again, you're not expected to have any prior knowledge of any of this. And you're taught how to both use them on their own, so to design software by itself or design hardware by itself, but more importantly, how you can design them to work together and to get the most from them. So we have three specialisms then within ECE. So it's as you said, a common first year across all engineering courses. And then second and third year, all ECE students will do the same modules. And then in fourth year, you choose between the three options. And it's essentially a software focus, a hardware focus, or kind of a mix of the two, how to ensure software and hardware can work together. So electronic devices and systems will be hardware focused, machine learning will be software focused, and then Internet of Things, which is what I'm doing, is a mix of the two. So this will be kind of embedded systems and things like that. So you have a great variety in what you can study and what you can focus in, and you're not committing to one option or another when you pick this course. That you can kind of really find what area of electronic and computer engineering that you enjoy. Yeah, if it's good. Next slide, please. Thanks.
God, the fancy
Yeah,
effects on your slides.
yeah. So it's just kind of a more examples basically of the kind of things you'd work on. So the Internet of Things is a very big focus at the moment. Just with the kind of desire to have everything connected, everything working together. So this could be your fridge being able to connect to your phone, or your thermostat being able to, you can control that from your phone, or if they want it to be that you can control your thermostat from your fridge, ideally, is the ultimate goal of Internet of Things, that basically everything's connected, all the data is shared, and um, you can get the most from your technology. And it's really it's a huge focus for the future of the world, really. And every project you see now involves software and involves hardware. And it was the main reason that I chose this course. Was I really enjoyed coding and writing software, but this kind of satisfaction of being able to hold your work in your hands, and you can see it doing what you tell it to do through your code.
Cool. Also just wanted to mention the cool video that's currently playing. We do a very similar project in third year of that, where you're basically making a self-driving car that can go wherever you tell it to go on the track, which I'll talk a bit about later as well for under our projects. So mechanical and manufacturing engineering. This is the anything that you can kind of see, feel, you get to design it. So it provides a broad range of experience in mechanical and manufacturing engineering. It is suitable for students that would like to work in the automotive industry, aerospace industry, product design, materials processing, manufacturing, power generation, biomedical, etc. You really would just be you'd be behind the designs, the prototyping, the building, every step of the way is the part that you'll be able to get involved in. It also, some people see it as a lot more practical option. You get to work on different types of projects. So the main themes would be the like computer aided design, machine design and control, and manufacturing and automation. One cool project that you'd get up to with the mechanical and manufacturing would be a boat project. So you get to design your own boat and 3D print it, 3D design it, and then we have a little machine in the basement that creates a current. You put your boat in it, and basically you have to keep your boat upright and go against the current. But it brings in all the skills of problem solving, design, and 3D printing all into one. So then you have mechanical and sustainability, which shares a lot of similar classes and similar modules as the mechanical and manufacturing, but this with a more sustainability approach. So some of the key areas would be renewable energy systems and life cycle analysis, energy in buildings and transport, environmental water, and process design. So again, this is a very much associated with design parts of it. Offers exciting opportunities to advance climate change technologies, energy decarbonization, and improve the quality of life. A cool project that these students get up to is, I believe last year for our year anyway, they got to design their own wind turbines, and they all got to hook up their wind turbines and see which of theirs was able to generate the most power the most efficiently. In engineering, we do like a little bit of competition, so a lot of our projects do end up having a little demonstration against each other, but it really is just great fun at the end of the year when everyone's in one big lab cheering each other on. So mechatronic, so this is my course, so I might be a little biased in saying it's the best, but for me it did offer the best of both worlds of both the mechanical and electronic side. So basically anything that moves and has a computer involved would be a nice overlap example of mechatronics. You'll see us in areas for robots and automation, smart machines and products, control systems, medical machinery, car industry, drones, anything you can think of that moves and has a computer involved. Um, it's also really nice. So, like, if you're on a team with both mechanical and electronic engineers, mechatronics a very nice in between if you want to be able to talk between the two teams. And also, it means when you graduate, you can take it off into several different directions. Um, and then we have biomedical, which I believe is back to Matthew there.
Yeah, so biomedical engineering, it's basically, as the name implies, it's focusing on medical devices. And obviously, this is an area of huge innovation, and it requires a lot of specific skills that maybe electronic and computer engineering or mechatronics might not focus on. And a big one of this would be the need to kind of understand how the human body works and the certain challenges that might be involved then with designing medical devices or prosthetic limbs or stents for arteries. Um, so yeah, as I said, you're studying biology to understand what your engineered solutions will be used for, but you're also um, studying the core engineering principles. So there'll be some mechanical engineering, some electronic engineering, some software engineering in there. But yeah, basically it's focused on the medical industry and addressing the issues that could arise from or that addressing issues related to medicine.
And they use a
Uh,
lot more precision than either of us because it's a big difference if you're doing
mm,
5 millimeters to the right in heart surgery and 5 millimeters to the right if it's your robot. I would not be good at for biomed. So projects. These are just an example of the progression that you get to go through with engineering projects. So on the far left is what you get to do at the start of first year. You're designing a thing called an AGV, an automated guided vehicle. So it's literally a small self-driving car. So at the start of first year, where you're just starting to learn how to design things at the very start, and you get what looks at like on the left-hand side. By the end of first year, you'll have what's in the middle. You get to fully design it, program it, everything like that. It'll be able to do your 3-point turns, follow a line, and go clockwise and anti-clockwise. And then by the time of the at the end of third year, you'll be able to do what's on the right-hand side, which is a fully self-driving little vehicle that can follow a track and go to wherever you tell it to go to on said track. That one was a really fun project that both mechatronics and electronic engineers got to do. The one in the picture, it looks like Pac-Man. We were encouraged to use our initiative and creativity for this project. So we got everything from Pac-Man to Mario Kart. Um, we literally got full control over the design that we got to do. Um, and these are just a couple of our other projects. Just these are more of the physical side. So these are overlap with the biomeds, the mechatronics, and the mechanical engineers. The weird one on a ladder on the left-hand side was our fireman project. And we got to design robots to climb up a ladder carrying a jug of water. And basically, whoever got to the top of the ladder the fastest with the most amount of water left in its beaker won the competition. It was a very fun little competition that we held across an entire afternoon. Very competitive, but it was great fun at the end of a semester to see your design up and working. Then you also have our intro placement with which both Matthew and I just completed in the last year. I just finished mine last month. So again, it's everyone gets to go on their intro placement. It goes from 6 to 10 months. Mine was lasted about 9.5 because I finished just before Christmas. And many students choose DCU because of this, because you're graduating with, if you're doing the integrated masters, you're graduating with already the guts of a year of experience. Real work experience looks great in your CV, and you can have placements in Ireland and abroad. And Matthew, would you like to share any of your experiences or inputs on your
Yeah.
placement?
So it's as Laura said, the intro was the main reason that I chose to come to DCU. It was that, along with DCU's kind of focus on practical learning in labs. They were the two main reasons. Because I found just through school and my whole life that learning while doing was the best way for me to understand what I was learning basically. So intra was obviously is a great benefit and it really sets you apart. I was working in a network device production company, so they made software for their network devices, and I was treated like any other software engineer there. I was writing code. Um, debugging issues. So I had the same responsibilities, but also the same opportunities to work on different tasks and to implement new features. And it's an experience that really stands to you. Now that I'm in my final year, I'm studying modules, I'm doing my final year project, and I'm constantly going back and using skills that I learned during my work placement on Intra. And then also for graduate interviews, having a 6 month or 10 month work placement really sets you apart because you know all the basics that everyone would have to learn during their first job. Um, and you are able to tell a potential employer that you can go in, you can start, and you'll be 6 months ahead of everyone else who hasn't done a work placement. So Intra is a great opportunity, both to learn and a great experience in itself to see what it's like to work in a professional environment. It could be an office, it could be field work. It depends on what work you are doing, but there's a great variety. And um, yeah, as I said, it's the main reason that I chose DCU to study.
Yeah, we've had students working all the way in Galway on solar farms and biomed companies in Dublin. So it really, there is a great variety in it. I myself worked with basically self-driving robots for my 10 months, as well as being put in charge of their entire 3D printing manufacturing processes. So you are given responsibility and get some great experiences with it. And then these are just some of the companies that we work with here in DCU. So you can see some very big names. Our students get experiences working with quite a fair few of these every year. So you see everyone from Pfizer to Google, Microsoft, Airbus, BMW. Believe there was a fair few people working with car companies in our year this year. They all got some great experience. And
And so just on that as well, there's
oh yeah,
DCU has one of the highest graduate employability or graduate employment rates in Ireland, and especially for engineering, just because of our hands-on learning. That we have a different set of skills than we would have if we did a purely theoretical degree.
yeah,
And on that, a lot of students who do their interplacements will get job offers for to come back full time as graduate engineers once they finish their studies. So it's another opportunity that, as I mentioned, you have that experience during your interviews to talk about, but also you have the opportunity to potentially get a job offer from the companies that you intern with.
yeah. That's a very good point as well with DCU. A lot of courses, it obviously they might suit you, have a theoretical aspect to engineering, but DCU makes sure we get a really good balance between the practicality and the theoretical. Like we have, it's every module is broken down to lectures, tutorials, and labs. So lectures you learn, tutorials you get to ask questions, and then labs we get to apply what we learned. So pretty much in every module we get that practical experience, and then we get to apply it even further with this internship. Then some of our entry requirements. So we have the general entry requirements for the university admission, and then specifically for engineering, we have a maths requirement. So you need a minimum of a H4 in Leaving Cert Maths or a minimum of H4 in applied maths with H5 in maths. Unfortunately, those are the minimum requirements. And there are other routes with some of the certain PLC college. I can't remember off the top of my head, but there are other routes to get into it if you are worried about these. So point requirements. So for common entry, it is 543. Electronic computer engineering is 531. Mechatronics is 533. Mechanical and sustainability is 533 as well. Mechanical and manufacturing 542 and biomed 544. So they're quite close together last year. But you would be hoping to aim roughly in around those requirements. Um, that is our presentation. There we've linked two different emails, one for the Mechanical and Manufacturing School and one for the Electronic Engineering School. If anyone has any questions, don't hesitate to throw them into the chat and we'll gladly answer them now. I can't see the chat, so Matthew, if there's
Yeah,
any
yeah, I
questions
can do
there,
that.
you'll be able to see them.
Yeah. And also we have our UniBuddy platform as well. So me and Laura and the other engineering ambassadors, but all the other student ambassadors are there. So if you have questions about the course, that's maybe not the academic side, maybe kind of the student perspective. If that's what you're looking for, then we'd be more than happy to answer questions there. So one of the questions is, how did you know engineering was for you? So for me, it was all through primary school and secondary school. I always enjoyed the kind of STEM subjects. Um, so like maths, science, those kind of subjects, and the kind of problem solving element to it. And then I went to the Coder Dojo one day, which is just a local coding introduction course. And I kind of just found that coding was the niche that I really enjoyed applying my problem solving skills to. So I would say engineering is a great course for someone who enjoys problem solving. Um, that you don't want any 2 days to be the same. You're solving different problems. Engineering is definitely something you should consider, and you'll be able to find the kind of the niche that you enjoy applying your problem solving skills to, whether it's coding or 3D modeling. So yeah, problem solving skills is the underlying kind of factor that I would say to point if engineering would be for you.
Yeah, I was the same. I really liked maths, and luckily I had technology in my school, so I always enjoyed the design part of that. I also really like art, which some people kind of overlook when it comes to engineering. If you like art and maths, engineering is a really good option because it gives you that creativity and a little bit of freedom with your design to bring that into like real world applications.
Yeah, so I studied DCG but didn't pick a science subject for leaving cert. I see a science subject isn't a mandatory requirement, but would studying engineering be too difficult without a science subject? So no, it wouldn't be. I studied chemistry, physics, and applied maths for my leaving cert, and while it did help when we were in first year that some of the concepts I'd seen before, we were taught from the very beginning. So our first semester of college was almost like a leaving cert level in science, in maths for the first few weeks. So the minimum requirements is the H4 in maths or H4 in applied maths and a H5 in maths, and you're not expected to know anything else other than
If
that. You'll be taught from the beginning.
Even our very first maths class, we were taught what an equal sign was, just to make sure that people weren't using little rhyming schemes anymore and to make sure that we knew what an equal signs were. So everything is literally from the foundation to make sure that you're comfortable and confident with everything going forward. So if it's not a requirement, then you'll be taught it in first year. Like I hadn't done any programming before and I absolutely love it now. It's one of the reasons why I went for mechatronics rather than mechanical engineering.
And then there's how long do your days last and how many classes, and then how much time do you spend working or studying outside of classes. So engineering has the reputation of being busy for a reason. It is quite a demanding course, um, but it's more than doable. You can have a social life outside of engineering. You can work part-time jobs outside of engineering. But
I
I
think
would say,
the clubs and
yes,
societies are basically run by engineering students. Like,
yes,
and
yeah,
every single committee has an engineer on it. So
yeah.
this we definitely still get around socially.
So like the days can be long. So you could, let's say, first and second year, maybe third year, you will be in most of the time, Monday to Friday from 9 to 5. Um, and then you have to study outside of that, but it isn't completely. You won't be completely overrun, and it's kind of as well how much you're willing to dedicate to it. Um, but yeah, so I'd say
I
expect
think
to be in 40 hours a week and studying on top of that. But
as much as that kind of sound a bit intimidating, I think it also is very helpful in first year the way it works out. Because you end up getting to know your classmates a lot better if you're in labs and stuff throughout the week in first year. 'Cause I know some people in other courses with far less hours and they still don't know anyone on their course. I think between Matthew and I would probably know everyone in our year
mm,
across all the disciplines at this point. So
yeah,
it definitely makes it easier for that, and it also makes it easier because we do a lot of peer learning. So we do a lot of study groups with each other. We do a lot of group projects. So getting to know each other in first year was also a huge help.
yeah. And then there's how do you choose between electronic engineering and computer science? So this was the main question I had before I was when I was doing my CAO list. Basically, the way I look at it is that electronic and computer engineering is coding is writing code for something. So whether that's the AGV that's on the slide there, or for a computer, whereas computer science is coding for kind of something virtual, so websites, databases. That's the way I'd kind of differentiate it. Is that the stuff you'll make in electronic and computer engineering and work on after you graduate, they're kind of physical devices that have to have code written for them. Um, and then computer science is websites and databases. But with electronic and computer engineering, you do get the benefits of you can go into hardware engineering, designing circuit boards, designing kind of not so much a software element if that's something you'd be interested in. So it's just whatever area you prefer to write code for. And then we have, does DCU have a Formula student team? So we don't have a Formula student team, but we have the solar racing, which I think Laura spoke about earlier, but they're making a solar car to race across Australia. So it will be very similar to Formula Student, except it's obviously a solar car with electric motors rather than a combustion engine. But yeah, you'll get very similar opportunities in the solar racing team that you get in Formula Student. So if there's any other questions there.
If not, again, you can send them in on UniBuddy to either Matthew or I or any of the other engineering ambassadors. Because there's also, especially since Matthew and I are mechatronic and ECE, there are other ambassadors on UniBuddy in the other courses if you want to ask them specific ones. Um, Other than that, always coming for like either open days or any of those is also a huge help because you get to see our labs and get to interact with lecturers and students on the day. Any other questions? Is that it? I
I
can't see
think
the
that's
chat, so I'm
everything.
assuming.
Oh, sorry. Yes,
Okay.
sorry, I forgot about it. Sorry. Yes, sorry. Yeah. No, that's all the questions.
Perfect. I'm gonna
Oh,
stop
sorry, someone's
sharing
just
now.
asking how do we use Unibuddy. So if you search up DCU Unibuddy, there'll be a tutorial and a link to the website, and you can go on and there's a whole page of all the student ambassadors and what we study. And if you choose me, if you want to talk about electronic and computer engineering, or Laura, if you want to talk about mechatronic engineering, or for any other course, and you'll be able to talk with us on there and ask us any questions.
Okay, hello everyone. Welcome to the DCU Online CAO Information Evening. Thank you for joining. My name's Eamon Maled. I'm a student ambassador here at DCU, and I'm also the Combis class rep for final years. What is Combis? I'll be getting into that later on. But thank you guys for joining. And what I'll be going through today is why computing is a strong choice, what DCU offers for computing, the career outcomes, and why DCU specifically. Great. So, computing is fundamentally about problem solving. Let's get that off straight away. Coding is quite a large part, but problem solving is quite a large component of what you're trying to do. You're learning how to break down complex problems. If it's a bug in a software or if it's a UI issue, you're trying to break it down into the most simple problem and solve it as fast as possible, which is quite a transferable skill. You're trying to learn how to think logically and build solutions that can scale as well. What do I mean by a solution? That's just a buzzword for how can I build something that I can offer to a customer and they'll buy it. These are all very transferable skills. These skills can apply to the tech world, the business world, finance, fintech, healthcare, startups. Even if you don't code forever, these skills will stay with you forever. Okay, that's what I'm saying. And studying computing, there's highly paid career options. You can work anywhere from the world. I'll be going into my own personal work experience, and I was doing hybrid work as well, and it was fantastic. Computing expertise helps in many, many other jobs, even if you want to break away from coding itself. there's great opportunities for creativity and innovation as well. So computers are incredibly fast and accurate and stupid, while humans are incredibly slow, inaccurate, and brilliant. Together, they are powerful beyond imagination. So I'll be talking about how there's a big fear in the computing world and joining computing these days. It's about AI, and will there even be a job field here in the next 10, 15 years? So during my work experience, which again, I'll be going on further on and saying exactly how it works here at DCU, but what the industry is finding and what everyone's kind of awakening to, especially in the industry, is an AI is better than a human straight off the bat. It has unlimited information, everything that humanity has ever made in its life, but it's not great at thinking on its feet. So what's better than an AI? It's a human working with an AI. An AI working alone will make issues, and it will send out a bunch of code that sometimes isn't even usable. And without proper supervision from a human, that's no use. That's no use to anyone. And AIs can go absolutely rampant and hallucinate all different type of work. So what I'm trying to get to is what a lot of businesses and the business I was working in, which is PwC, realized, and about halfway through my work experience, was that it is much better to have a human working with an AI to get the job done than it is to have a human by himself or an AI by itself. So the programs that are at DCU offers as well, there's three in the computing faculty, which is a Bachelor's of Data Science, which if you're interested in data information, this is for you. Data scientists are investigators, storytellers, and problem solvers who organize information. They're trying to get information and data that is so large, a lot of junk, and trying to make something usable out of it. There is the Bachelor's of Computing for Business, which is me, or COMBUS for short. If you're interested in the broader dynamics of computing and IT and business, this is for you. Careers are in computing and IT management. The kind of buzzword for this is we're trying to bridge the gap between someone who knows absolutely nothing about computing and someone who knows absolutely way too much. And how do we get these two people to communicate? That's where we come in. And then there's Bachelor's of Computer Science. You're interested in programming and software development. You're looking at building the most efficient solutions for businesses, building startups and knowing absolutely all of the technology behind it. This is for you guys, okay? So these are the requirements to get into each of the different faculty. So the three different courses that we offer here. It's data science. The CAO code is DC123. It's a technical degree. There's software and maths, heavy focus on maths. So this is a big part as well. You'll see with the other two courses, it's an O4 or a H6 minimum. But with data science, there is a hard requirement of a H3 in mathematics. Okay, so the points in 2025 was 500, and you need a H3. There's no alternative for ordinary level, and it's higher than a H6 in the other one. So you really need to make sure that you nail the Leaving Cert mathematics to be able to get into data science. And plus, just in general, the course is very maths focused. So knowing a good strong background in maths would be quite helpful for data science, but it's not needed because with all courses here in DCU, we build you up from nothing and then we get you out the door knowing hopefully the idea is most of everything. Next is computing for business. That's me. I'm a bit biased here, so I'm going to say I love this. This is my bread and butter. Our CAO code is DC120. It's a blend of technical and business. And the minimum is a O4 or a H6 in maths, same with computer science. And the points in 2025, that's it's 514. That's a mistake there, but it's 514 points. That should say it on the next few slides. And in computer science, 414, not 514, it was 414. Computer science, it's CAO code DC121. It's a technical degree. It's software and maths. Maths not as focused as data science, but it definitely does have maths and a lot of logic based on it. The same requirements are for maths in computing for business. It's an O4 H6 in maths. And the points in 2025 was 487. So I'll go more into depth into data science now. So what is data science? It's the visualization of data. So you're going to get a lot of junk data, which that's very common in today's world. Even if you're training AI algorithms, you're trying to get data and making it usable to actually feed into these things. There's so much information out there. There can be lies out there. There can be miscalculations. There's so much wrong information out there. And we're trying to get something, some semblance of usable data from that. And that's what you'll be focused on. So you'll be doing statistical modeling, statistical computing, data technology, data research, consulting. There's real world applications for this data as well, be it healthcare, the automotive industry, you name it, everyone needs data, and that's why they're so in demand. Everyone needs data in this data-oriented world today. So data scientists are regarded as one of the most in-demand roles in industry at the moment. That's by far so true because everyone needs data. The modules you'll be learning is mathematics, statistics, computer programming as well. So statistics-based programming such as R. You'll also be doing Python as well, but a big one is R. Data analysis, you'll be learning communications and visualization. So it's one thing to know how to get this data, but it's another thing altogether in how to tell everyone about this data. So there's communication and visualization. It's getting really nice looking graphs so you can tell people this is the data I have collected for use and this is why it's so good. So have a look at my data essentially. So just to go back into it, it's a bachelor's of data science. The requirements 499, 500. So that was 2024, 499, 2025 is 500, I believe. But there's work placements, which I'll be going into a lot about. Work placements, it's about 7 months. It's the same as computing for business. Now that's 7 to 8 months, depending on the company you work for. So there's a lot of diversity in the business that you go and work for. But the main point is it's about 7 to 8 months and it's paid, which is really, really nice. This is all over Ireland and abroad as well. But DCU is great for getting a lot of very well-known large companies into DCU and offering places. So, and they're all paid. And if you're looking for something outside, abroad from Ireland, you need to go and sort it out yourself. But DCU, you can talk to the intra officers and they're very helpful. I know many people who went and studied in Spain or England and they went and sourced out these opportunities and came back to intra office and they were lovely in organizing how it worked. Next on, we have my course here. So that's School of Computing, Computing for Business. The focus on the interface between computing and business. So as I was saying before, it's trying to get the person who is all intertwined with computing and someone who knows absolutely nothing about a computer and getting them to be able to talk together. It's something what I think is very interesting. It's bridging the gap between them. So the modules you'll be learning is programming fundamentals. So that consists of Python and then also web apps. So that would be HTML, CSS, and then full stack, which is Django. So that's making real functional applications online. There's data analysis and visualization. So we steal some of the data scientists' modules and we hop in with them and we learn all about data analysis and visualization, which again is showing how to best show off the data that we've collected. There's business systems analysis. So every business runs off of IT and they have systems. So we need to know how they work and how to best integrate systems in. So if you're thinking about every business, they need to know we need to get them online, and the best way to do that and get all the employees as efficiently into it as well. And then we'll learn a lot about innovation and entrepreneurship. That's in final year. So a big thing is sort of starting your own business, learning all the documents that you need to know and how to get your business off the ground. So I'm in final year now and I'm launching my own entrepreneurship business currently. And that's a big thing. So final year, it's not so much time inside lectures. I'm only in 2 days a week at this point, but a lot of it is getting our startup up and running. And hopefully it's something that we can continue on post-college. So DCU is great in a sense where they'll get you all the tools that you need to get your own practical business up and running and continuing on if you want to. There's project management as well, how to be a team leader, how to make sure that every project that you're starting off is going as efficient and appropriate as possible. And then app development, I was saying. So that's full stack. and you learn. So what we do is Django, which is a Python-oriented development. You do that all through the 4 years. First year is very much based on getting you the basics and the fundamentals on programming, and then all through each of the years. So first and second year is really building up your fundamentals. Third year is kind of testing you, and then half a third year as well, which is from January all the way until September for myself, was working off into the field. And it's I cannot stress how great it is to actually go out into the field and put your tools to work and getting paid while you're doing it as well. And then so it's a 4 year long degree. It's 7 to 8 months. Again, very much dependent on the internship that you land, but it's about 7 to 8 months. It's 414, as I said earlier, and there's no real prior knowledge necessary. DCU is so great at building you up from the very basics all the way up to the top and kind of showing you how everything you need to know. And you need a minimum of an 04 H6 in maths. That's the only requirements as far as subjects goes. And then computer science. So this is the big one. Focuses on programming and software engineering. The modules you'll be learning is a lot less business or data oriented. This is programming and analyzing how to program as best and as efficiently as possible. So you'll be programming, you'll be doing analysis and design, web design, networks and internet, operating systems, cryptography, and computer graphics. So this sort of thing is very based on software engineering. So academia is a big thing that I would say the difference between computing for business and computer sciences. So computing for business, we're teaching you everything that you need to know to land a job. That's the big thing. Getting the job, getting you out the door, getting the job. As computer science, while that's a big focus as well, but there's also a focus on academia. So if you want to move further, get into a master's, get into a PhD, and do a lot more academia based on computer science and become a computer scientist rather than a programmer or software engineer. So computer science, their placement is shorter because they stick on for a little bit later. So computer science, computer for business and data science, third year, January, you go off onto your internship, and that can last anywhere until July, all the way until September. My one finished September 5th, and then I was back in college September 12th. So basically finished my job right back into final year. But computer science, they head off towards February, March time. That's because they do one module, and they do a project as well, just to teach themselves or their showcase what they're doing. So they have a little bit less time out in the field, but they're still learning something here. Of the optional modules, because there's 3 modules, there's one that's taught by IBM, which is very interesting, but there's one for machine learning, and then there's one which is communications as well. So you can choose one of those 3, and then you head on after that and you go into the field. As I said before, there's no prior knowledge needed for any of these, but there is the 04 H6 in maths that's needed, and 498 points needed to get into computer science. So where do graduates work as well? So this is a big thing. DCU is fantastic for getting you out the door with a job, and a lot of these places come to us during your internship or your intra placement, which is in third year. So just a few of the places that are big that work. There's Shopify, Intel, Samsung, Microsoft, Nintendo, Netflix, Meta, Apple, Paddy Power, Spotify, Amazon, and Workday. So I know a big one for us anyway was Workday. They offer quite a competitive salary for their interns. So when we're talking about the internships, everyone gets paid, but depending on the company that you go for, obviously, you're going to get paid more, and you're going to get paid more after college as well. So a big thing as well is when you're working on your internship, if you show up and you're doing the best that you can, there is a lot more of a chance that they're going to take you on afterwards. Sure, why would they go out and look for anyone else when they know you? They know that you can work hard. They'll just offer you a graduate program. They'll offer you something and they'll come back in. So the best way to secure an internship in third year, this is just a bit of advice that I personally wish I knew when I was going in, is they will look mostly at your grades in second year. Okay, I know I'm jumping the gun here, but just for anyone who goes and continues on here, something that I think everyone should really know is second year is what matters to get your internship in third year. Okay, and third year is what matters to get your job afterwards. So the way that the internships work as well is come the start of third year, Intra starts sending you out emails, and they have this whole portal, and they go, "Hey, these are the companies that are interested in picking up a few of you guys. Please apply." And then you apply with your grades from second year, and then you go and do interviews, which is really good experience nonetheless. This really shows what an interview in the real world is like for these big companies. And then you jump in, and then from the second part of third year, so your semester two, you're basically off working the entire time as well. And then these are the future careers. So data science, I'll just fix that over here. Data science is very wide. I mean, every single company out there needs someone to handle their data. So they're fraud analysts, they're sports data analysts, deep learning engineers, that's environmental data scientists, and so much more. I cannot stress how many job opportunities are coming out for data scientists. It's healthcare, it's financials, anything. They all need data to know who their target customer should be, and that's what you are meant to go and get for them. For computing for business, your tech entrepreneurs, your visualization engineers, your business analysts, your enterprise application developers, and also your software engineers. I personally went and I very much enjoyed the coding more than the business side of computing for business. And so that's great. They said that's great. And I went and I applied to the software engineering roles, and I got into them, and I became a software engineer at PwC. Computer science, they're very much focused on the get yourself programming. So your gaming developers, your ethical hackers, your software developers, and your tech entrepreneurs as well. But so computer science is very much based on coding and programming. Computing for business is based on a bit of a hybrid. There's a bit of a, if you want to go into the business, that's great. You can go into business and kind of forget all the coding you went, but it'll stick with you nonetheless. If you want to really go into software engineering, you found out that's what you really, really enjoyed. That's grand. You have learned the basics and sort of the mid-tier stuff that you need to know to be able to land a job in that as well. And then there's data science, which they learn programming, they learn Python in first year, but they also learn a lot about data. So you're kind of stringent on going into data and very data focused things. So you very much like data, that's where it's at. And everyone will want to pick you up and try and get you into their company just so that you can make some sense of all the data that they're collecting. Career prospects. So this is the big thing. Everyone loves tech because of the salaries. Computing graduate salaries relative to other disciplines is very, very high. This trend of higher salaries is likely to continue, as reaching 120,000 within 5 years is very achievable in tech-driven markets or industries. So I'll just say some people that I know, they've already landed jobs at Amazon and they're six figures already. Okay, it's very achievable to get out of the gate with a six-figure salary. You can go abroad and it's even more achievable. The salaries here in Ireland, I mean, they're good, but abroad it's very, very good. And I know a few people already who have six-figure salaries, which is very, very impressive. And it's achievable. That's the best thing. It's not one in every 1,000. It's one in every, I don't know, 30, one in every 20. It's achievable to get these high salaries. And that's great. Who joins tech? They love tech, but they also love money. And this is a great point. Some notable alumni here, we have CPOs, CVPs, CTOs, co-founders, and serial tech entrepreneurs. So that's something very big. We have a very long history of notable alumni here at DCU. You finish off, you're set up for life, and the alumni program here at DCU is very great. They love having you back and talking. So this is a big thing about the career prospects as well. DCU ranked first in Ireland and 23rd in the world for their actual rate of graduates' employments within 12 months of course completion. This is great. I mean, everyone's going to college, and you kind of want to know that after the 4 years of your hard work, you'd like to know that DCU does offer some semblance, the statistic of you will have a job afterwards or some sort of graduate employment. So that could be in academia as well. If that's computer science, some of them head off and do academia roles as well, and they pursue their PhD. But regardless, there is something for most people here in DCU. You'll be leaving and you'll have a job, and that would be lovely because the past 4 years that you've worked has meant something. And it doesn't need to be computer focused, but it is great if you've found out that you absolutely loved it. But if you had differed away from it, it's grand because there is opportunities outside of computing because these highly transferable skills you'll be learning are very transferable, and we are great with career prospects afterwards. So why DCU? The courses are designed for industry. School of Computing is committed to developing innovation, industry relevant courses. That's a big thing that I'd like to hammer home. The courses are very practical. We're not just sticking a book in front of you. We have a computer in front of you. You're learning about coding. You're learning about industry coding. You're learning about what you need in the future to actually land a job. We're ranked first in Ireland for graduate employment rates, which again is fantastic. The school is involved in several world-class research centres. So that's Insight, Adapt, and Lero. So they're on campus. And a few people that I know actually landed jobs with them during their internships as well, which is great because they actually got a lot more ingrained into university. And now they're very much interested in leaning, going further into academia as well. We have a diverse student body. Over 1/3 of the student body is international. Well, we have a very large international community here, and it's really great. And the committees and societies surrounding it are fantastic. There is a committee and society for basically everything here in DCU. You name it, there's one. Bachelor's in Computer Science, the large computer science degree in the country, constantly reinventing itself to make it more and more industry relevant. And a lot of industry leaders come into DCU and come into the computer science and computing for business and data science and host large talks talking about the future, and we learn from it. And every year the course is changing in some small ways, but keeping it relevant, making sure that we have the best output of students as possible. Bachelor's in Computing for Business gives students a flexible basis to work in computer training in industry. Yeah, so I know a lot of people in my course that they've enjoyed the computing, but they know it's not for them, and they're going into, so the people I went to in PwC, they ended up not enjoying the software engineering, but they did enjoy the business role, and they got business role jobs offered to them afterwards. So they're going, and a few of them are offering them to paid masters, and they're going to go into do tax, and they're going to go into business and project management and leadership roles off the bat, which is great. And the diversity that we offer in the class for all the different sort of teachings that we offer is great. So you're never sort of bored sticking on one thing. There's always new things being thrown at you. And then Bachelor's in Data Science, it's the newest degree in the School of Computing, and it is the fastest growing computing sector in country. Lower student teacher ratio in the classes makes it a lot more individual tuition. Yeah, so computing for business and computer science, they are very large classes, 100 plus in first year easily. Data science is a lot smaller, which is very nice. You'll get to know your lecturers will get to know you for data science, and that's very helpful because the modules you'll be learning are very maths focused, and it does pay off to know these people, and they will help you a lot better. So that kind of brings me to the end of my talk. For any queries, you can talk to computing secretary here at DCU, and there's also the link here for the website for the School of Computing as well.